Welcome back. This is an Aleks homework video on using an equilibrium constant to predict the direction of spontaneous reaction. Seems really hard, but it isn't actually really hard. So really what you're wanting to do is at the beginning of a reaction, it's not at equilibrium. So really you're not at K yet. So when you're looking for a concentration constant that they give you here at the beginning, they give you 1.6 as a constant, an equilibrium constant for this particular reaction. Before it goes to reaction, it's still kind of working, it's still moving. So it's either moving to the right or moving to the left. So it hasn't reached equilibrium yet. K is when it's at equilibrium. At equilibrium, it's not moving any farther forward or backwards. Whatever the products are kind of constant, whatever the reactants are kind of constant, and it kind of just sits there. While it's moving, you don't really call it K, you call it Q. Now, when I first learned Q and K, I don't know why that seems so hard to me. All Q is K before it gets to equilibrium. So it's the concentrations of the products divided by the concentrations of the reactants. Okay, so what's going to happen is if Q, okay, in this case I just put in the numbers that they gave me for A, the two products divided by the two reactants for B and for C, got a number, and then that number is either bigger than K, equal to K, or less than K, right? If it hasn't reached K yet, then it is still moving to the right. If it's overshot K, it's going to move back to the left. So if you've got a Q that's less than K, it's going to move to the right. That means more products are going to be made and more reactants are going to be used up. If Q is equal to K, then you're at equilibrium and it's exactly the same. And if Q is bigger than K, then you're going to go to the left. More reactants are going to be made and more products are going to be used up. So that's cool. That means it's not hard. It just looks hard. It's terrifying, but it's not really a big deal. So when I did the numbers in reaction vessel A, Q is less than K. All right? If Q is less than K, then what's going to happen? All right? So if Q is less than K, then HCN, which is a reactant, is going to do what? Well, if it needs to go forward, then it needs to decrease. Okay, so any of the reactants will decrease. So that means that the NH3 will decrease. And what will happen to the products? They're going to increase. When Q is bigger than K, it's going to be exactly the opposite. These guys will increase, these guys will decrease. And that's the same thing that happens in the third one. Since Q is bigger than K, then you're going to get an increase in the first guys, and your second guys are going to decrease. So you'll have an increase here and a decrease here. I hope that demystifies Q's and K's. It's not as hard as I once thought. Maybe it's not as hard as you think. Hope you do well.